Hey everyone, today we are going to deep dive into something that has been absolutely blowing up in the Python AI community. It's Pydantic AI. If you've been wondering how to build an AI agent that don't break in production, stick around uh, because we are about to build something seriously cool stuff together. So here's the thing, we have all been there. Imagine like you are trying to build an AI agent, maybe chatbot for your business or data processing assistant. You are using raw OpenAI SDK or maybe LangChain, for example. Like if you have LangChain, so you might all be familiar with LangChain if anyone is doing some serious stuff. So everything works. I mean, if as far as the LangChain, everything seems working fine until it is in the local system. But then you deploy it to production, and suddenly everything falls apart. So the what happens is like the responses are inconsistent. Your data validation is literally non-existent, and debugging feels like you are trying to find a needle in a haystack. So now if I told you there's a framework that's designed from ground up to solve exactly these problem. What if I told you it's built by the same team that created Pydantic, the library that literally makes every major AI framework uses under the hood. And what if I told you it makes building AI agent feels like as smooth as building an fast API application? So that's Pydantic AI, and today we are going to build three different AI agents from scratch, starting from simple and working our way up to production ready systems that could actually deploy and use in real world systems. So uh, uh, before anything, first you should come to the ai.pydantic.dev. Here you'll see the complete documentation. This is what we are going to follow, and so you should ask yourself this question whenever you are watching this video: what is exactly Pydantic AI? If we head over to their official documentation, you can see here they describe it as a Python agent framework designed to make it less painful to build production grade application with generative AI. Now the key word here is the production grade. This isn't just another wrapper around OpenAI API. This is a framework that's built with same philosophy as FastAPI: type safety, developer friendly, and reliability. So think about this way: what FastAPI did. FastAPI revolutionized the web development by making it incredibly easy to build robust APIs with automatic validation and documentation. Where the Pydantic AI is trying to do the same thing for AI agent. So let me show you what that makes things special. So if you can see the providers, I will head over to the example model providers. You'll see there are a lot of providers: OpenAI, Anthropic, Gemini, Mistral, Cohere, Bedrock, Hugging Face. So the models support is really good, works with all major providers. And the second core principle is the structured responses. Your AI outputs are validated Pydantic model, not just a raw string. In the type safety, everything is properly typed so that your IED can actually help you. Dependency injection for testing and clean architecture. And there is also the built-in observability, which is the Pydantic AI's log fire monitoring system. So you can also check log fire Pydantic. This is the one where you can do the telemetry, meaning you can trace all your, you can have a cloud server where your OpenAI traces are all over present over there. So this is a paid services, but alternatives are also there like MLflow traces. Tracing, you will also make one more video explanation how you can use MLflow observability. This is all some serious stuff, like this is a production stuff. So now we'll start doing the session, and we are going to start with uh, the first setting up of our environment where we are going to do all of our coding session. So first of all, head over to UV Astral and come click on this link where it says install on Mac Linux. Copy this string and head over into your IAD. Preferably make a folder. You can paste if you are using Mac OS or Linux. You can directly paste this command. There's also options for Windows. I am using my Mac, so it is going to work for me. Now it says everything is working fine. UV is installed. So let's check UV hyphen version. So it says 0.8, which is fine. Now we are going to initialize the project. So to initialize a Python project, you should first type UV init. It is going to create some files for you. It's the git ignore main pyproject.toml readme. By default it does it all of this for you. And now we'll go back to Pydantic AI and we'll use the Grok because I want this tutorial for everyone. Grok provides free API key for your learning. I mean, as soon if you are using it for production, you'll have to uh, purchase their enterprise license. But for learning and development, Grok is sufficient. So let me also open that. Now let's head over to the installation. We'll click on the UV command and it is saying UV add Pydantic AI. So what it is going to do, if you'll see the pyproject.toml, the dependency array is now empty, meaning it does not need any, this Python is project is completely empty now. So before doing that, we'll first initialize our separate virtual environment. So we'll type uvvenv hyphen python. Let's specify a python 3.11. This is completely optional. If you want, you can do that, and once it is done, we'll activate the Python environment with source dot when activate. So if we see which Python, so it is pointing to our only this is the exact folder which it is pointing right now. So now we can add add, we can go again back there, copy this command, we can paste, and look what it does. In the dependency array, it completely populated the required dependency for this project to be run on different environment as well. So uv.log is something that you don't have to worry about. It's just there to uh, keep a track of all of the dependencies. Now once you're done with this, let's go to grok.com. Let's go to start building. Let me do a login. So let's create an API key. This is the API key, but I am going to invalidate it after this session. Let's create an .env, and we will make a grok API key, and we can paste it over here. And since we are using the .env, we should also add the python.env. So this will make us it easier for us to do the loading of this key. So come over here and you'll see there is a template code which is written in the for you to basically see if everything is working fine. So we can just test what happened. Let's go here. Just to run a Python file, you will run main.py, and you can see this got printed, which means we are good to go. And we can also do one thing. So we'll also right now my just to verify if my ID is also picking the right environment. So there is called select interpreter. This is the environment that we want, and then we can do developer reload. There is a command reload window. So this refreshes everything. It syncs all of our dependencies. Now that we have our grok key, let's go to the grok example. So I hope that I am using the correct name. If we go there, let's see. Yeah, it was same. So now let's come over to, we'll make a separate one, which is the 001 py. I don't think so it will allow it. All right, zero py. So this is how you have to initialize the agent class. We are following the documentation. So it says from Pydantic AI import agent, Pydantic AI import agent, and once you imported it, we'll have to do the initialization. So the agent class we are initializing, and we just have to specify. Look, the type hint is telling us what should be the first argument. It is model equals the model string. So we'll search for grok, some model that has the capability to do the tool calls. So let's call llama models. OQ llama, actually let me copy it. Versatile. So that's how you get the model, and there are like other ways as well. So one quick note here, while we are using the grok today, remember that Pydantic AI is a model agnostic, and you could swap this out with Anthropic Claude, Google Gemini, or even local model with Olama as well. So now let's do one thing. We'll first try to see if this runs. Clear and uv run o1.py. Okay, so we have to from .env import load.env. Now this should work. Yeah, so the code ran successfully. We have not invoked the agent. I just wanted to show this is how you connect your local code to any AI provider. So in the next file, we are going to prepare one example where we are going to make an agent that will collect the weather information, and we will get it in a structured manner. So let's create the example. So let me make the folder basic agent example. So let's make a main.py here. So let's start doing the coding from Pydantic AI import base model. So from Pydantic import base model, and sorry, this comes from Pydantic itself. From Pydantic import base model from Pydantic AI import agent. So we'll have to first define our structured response. So let's define our response format. So let's make it a weather response base model. So for weather, we'll have to define. We are what we are doing. We are giving the base class, and we are inheriting the base model. So what is it? You can do a command click or control click. This is the class that we are going to extend. It has some inherent functionality, and we are going to utilize that. This comes from the Pydantic. So let's make location str temp temperature. Let's give it a int condition, that would be str, and recommendation, it is also in string. So we expect our LLM to get the response in this format. So now let's make the weather agent same way we did in the previous session. So now what we are going to do, we are going to tell it grok, and let's take a model llama 70 billion versatile, and we want now, this is where you can force your model to give the result type as weather response. So it will force the model to give the response this way. Then you will have to define a system prompt. So you can say you are uh, helpful weather assistant, always provide temperature TPRATURE in Fahrenheit. So let's keep the prompt short. Now, so the main thing, model, response, and the prompt. So this will make your agent, it is sufficient for the agent to give the information. Later on in the more advanced tutorial, we are going to hook an API that will give the exact values. So let's try to invoke our agent. So let's do dunder name equals to main, and we are going to get the result is equals to where the agent dot run synchronous, and we can ask what's the weather like in the San Francisco. And we are going to, let's first print the complete response, and then we will see uh, how we can parse that response. So we can do uv run, it's in the basic agent and main. Okay, so again from .env import load.env. So now let's see, let's again run the above example. So there is an error, did not match the schema, result is sunny, let's go temperatures. And there are some error, status code is 400 from llama 3.3 versatile. Let's try to run it again, maybe there's some error. Okay, so from the error, it is expecting this to be an integer, but the model is returning it as a string. So let's try to make it as string. Yeah, so it works. So the problem that we were getting, the temperature, it is returning as 65 degree Fahrenheit string. Now here we did not specify the model to only return the value. This is what we are going to learn about fields in Pydantic, where we can tell our model to use the correct response. I mean, we can have a response level control. And there is another error, which is there is a depreciation warning that we are getting, is the result type is depreciated, use output type. So we can do that so that this warning will go away. Run the basic example and it's working. Again, you can see that it's right now every time we run it gives a different output. So this is very unpredictable, but this is a basic example. Here you should more focus on how can you get the result and how can you parse it. So next what we are going to do, we are going to parse it. As I said, the output is a Pydantic model. So let's see if we can parse it. And you can also like do a type validation. It's typed to be weather response. So now you see how our IID is going to help us in the result parsing. So let's say location, and yeah, now you say result dot look. Now auto completion is coming because we have specified the type. And the temperature, and we can go result dot data, I guess, result dot temperature. Again copy this line. Now next is condition, and then the recommendation. Now let's see, has no attribute location. I think it's there. Okay, so it's a agent. We have to do result dot data. Sorry, result dot output, or you can make it output. A better way would be to remove this error, is to get the output from here, output, and this is weather response. Now I think it will work. Hopefully we'll get rid of all of the errors. Alright, now we were able to parse the result. Why did this happen? Because the agent response is also a structured, and our model output comes under the output attribute. from there our base model that we have defined will work. So now this is where Pydantic AI really gets really interesting. Notice what just happened. We did not get back new a raw string that we have to parse and hope that is in the right format. We get back a validated Pydantic model and properly typed field, and when it was not doing it, it was giving us the correct error that where exactly which field is getting break. So now imagine that the same thing, that the AI is returning an invalid temperature. So now we'll see how Pydantic AI will automatically retries to validating the error until it gets the right, and everything in is properly structured and typed. This is the foundation that makes Pydantic AI so powerful for production application. Now we are going to move to uh, where we are going to add the tools and dependencies, and this we can consider as to be intermediate example. So let's make an folder, tool and dependencies, and we'll make a file main.py. Again we are going to re-implement the same weather model but with improved capabilities, such that will give our model ability to execute the tools. And we will also right now will mock the data in this example, uh, and after that we are going to build a production ready in example as well. So let's start building this intermediate example, and this example will show you how to add tools and dependency injection, which is one of the really good feature of Pydantic AI. So let's do one thing. Let's import port httpx. We need to hit some API this time. So from data class, import data class. From Pydantic, import base model and fields, because this time we are going to control the out fields. So from Pydantic AI, import agent and run context. From typing, import list. These are going to be helpful. So first let's define the dependencies. So we'll use the data class decorator. So class, let's define a class which is called database connection. We are going to mock the database calling and all. So let's make database connection, and it's better to annotate your class. So we'll see mock database connection, and we'll make it a async def get user preference. I'm just defining a function for our database, and we'll give a fake user ID, and it is going to return our dictionary. In real life this would be a query to database, but right now we are going to hard code return a value. So let's make a temp Let's return a user preferred temperature unit. Maybe it is Fahrenheit or Celsius. I'll put a Fahrenheit. HEIT, and then ACTIVIT activity preference. Let's give hiking, photography, rest restaurants. So let's also make one function that is going to just print the preferences for a user, just so that everything is become handy. So let's define a async def class log user pref log, let's say log recommendation. Self user id is going to be integer, the recommendation, let's also make it string, and we are going to print it f log user relation for the user with user id and their recommendation. So this is just an helper function. Now let's define our response. So let's make a data class weather dependencies. So it requires user id, that is going to be integer, db, which is database connection, and weather API key usually, but for now just let's make it a value. So this is a weather database API. This is just a mock class, and let's now make a response model. So class weather data and the base model, we are going to inherit that. Now let's make first field as temperature. It is going to be a float value. Condition is going to be a string value. Humidity, and it's going to be an integer, and wind speed, let's make it a float. Now let's also make a class for personalized weather response. Personalized recommendations, which is going to be list of string, and in the field we can actually define what we want. So here you can see field, and we can give it a description. uh, Recommendation based on user preferences, and so that we can steer down the output. And let's also make a safety alert. ALERTS. It's also a list of string. Make it a field. Let's give it a description. Let's ask for any weather related. Safety concern. Now we'll make our agent. So let's do whether agent is agent, and then we are going to use grok. This time let's see if we choose a better model. uh, 90 billion, 70 billion, llama 3, kimi k2. I'm just choosing a better model that has the functional calling capability. Let's start with Queen QWQ32 bit, and if it supports the tool calling, then that's really better. And let's also, now we can define dependency types. We can give the weather dependencies, and the output types is going to be personalized weather response, and we can make a system prompt. Let me define it. Let's define the system prompt. So you are an advanced weather assistant that provides personalized recommendations. And we can also say use the available tools to get the real world data from the user preferences, provide the specific actionable recommendations based on the weather and users interest. So far so good. Now what we just have to assign the tool. So let's assign weather agent dot tool. This is the decorator, so it is going to be async def get current weather, In the context, we will give the run context, and we are going to define the weather dependency, and also will take a location, which is string from the user. So let's also give it the doc string get current weather data for a specific location. Now in real world implementation, this would be an API call. Now we are going to just mock the weather. So now let me define the mock data. Mock weather, it's going to be let's the first one was the, let's make a San Francisco. Let's define the data. So we have temperature as 68 degree Fahrenheit, condition, let's say partially cloudy, humidity. I am doing it with uh, the same base model that we have defined. Humidity is 65, and when it's time, let me copy it and we'll do it for one more location. Let's this time let's make New York. Let's define temperature to be 84, condition, let's make it sunny, and humidity, let's make it 70, and let's make the wind as 8. So now let's make a way to collect this information. So weather is going to return mock weather dot get location dot local lower, and if for some reason we were not able to get a response, we are going to give a default response as this. So this is a type safe way of doing it, otherwise it can break the code as well. So this way we are going to return the weather information as a string. Weather is in location is location, and we are going to fill the details. Weather is the temperature, degree Fahrenheit, and the rest of things like weather conditions, yeah, conditions, and then what do we have? The humidity, and the weather wind. Perfect. So this way, when the agent is going to hit this tool, it will give the uh, ability to retrieve this information. Now we are going to do make one more tools, like tool that can hit our database to retrieve the user preferences, and our tool that can log the interactions as well. That will be more handy. So this way we are giving our agent three tools. First is the weather itself, second the user preferences, and third one tool is to log the information for agent. So let's make one more tool, and this time now you will start to see, you will get used to of doing this thing. Let's make async, async def get user and this context, run context, weather dependency, and that's just what we need for now. And now we will see how we can invoke the mock database call. So first thing first, make the docstring, get the users activity and settings. So the preferences, let's make it await, context dependency dot db dot get user preferences. So context dot dependency dot user id, because our context has these information like user id and db. So this way we will get the preferences. Now we can return f user preferences is preferences. So that's how you make your AI agent invoke any database. Now let's make the another tool, weather agent dot tool async def log interaction. So context, run context, and we can give the weather dependency here and also the recommendation, and it is this, it will be a string str, and it is going to return a string. So log the recommendation for analytics. So let's make a call await context dot db dot log recommendation. We can pass the dependency dot user id. See how our ied is giving the uh, correct response, because we have defined everything in the type saved. So we just don't want to show, we just want our AI to show that it has executed this tool. Now we are going to use this agent. So let's make an async main and let's define our dependencies. Whether dependencies, let's create it, make user id as 123, db, let's give database connection, and whether api key, let's give it api key. Now result is equals to await whether agent dot run. This time we are not using run async because our function is asynchronous, and we are going to give a prompt as I am planning outdoor activities in the San Francisco. Today, what do you recommend? So this will make our agent to force it to make a weather API call, and also the user preference call. So once that is done, it is going to give us the output. So let's do some formatting and let's print the result, print, and also let's do one thing dot output dot data print temperature result dot data, sorry, output dot weather dot temperature, and condition. So it will be weather dot conditions, and then humidity, and then speed. Do we need anything? Yeah, so for personalized recommendation, we'll see first if this is working or not. So if underscore name is equals to name, import async io. So async io dot run, it's going to be main. So let's see if it runs. Okay, it's showing an error here. Okay, so uv run to main.py. All right, .env. Okay, okay, so it has been, the model has been decommissioned, so we'll have to uh, use another model. Grok 4. Let's see if we have the access. Okay, sorry, so it has to be Grok Q. Let's see, let's stick with the llama. Llama 70B versatile. Hopefully this time it will work. Yeah, so see here it has given us the output. So this is the output that is coming from the API. Now let's also see if we were able to get the user preference. For result data, sorry, output dot personalized recommendations, because it's an array. So let's see. Recommendations for, let's be were also giving the alert. In result dot output dot personalize dot safe dot output dot safety alerts, and we are going to print slash in a new line Now let's see if it invokes the database. Yeah, so as per the user mm, safety alerts, it is saying be careful, too strong winds and bring an umbrella. uh, so yeah, that's how it works. Wear a jacket. So let's see if it was in the personalized recommendation. So this is where the Pydantic AI really starts to shine. We learn how to do the dependency injection working seamlessly. Our agent can access database connection, API key, user data, whether it needs. Tools are just regular Python function with decorators, making them super easy to test and maintain. And notice how the agent automatically figure out which tools to call in what order to answer the user's question. So this is what we call system 2 level thinking. And the agent outputs provide personal recommendation. And so for an advanced tutorial I am going to link the GitHub repo code, because this session is has become quite a long, and we will continue building the more application with in next tutorial with Olama, uh, which is using our local AI model, and then after with the open AIs. So this will be short tutorials. After that we are going to learn the graph of Pydantic AI, and that will complete this playlist. So thank you for watching. Please make sure to subscribe. Bye.